Okay, good morning class. So today we're looking at exponents and surds. So yesterday we did exponential equations, the division thereof. Okay, so today we're looking at the more complex exponential equations. This is on page. This is page 9. Correct?
Yes.
And this example is for exercise 1.5, which is on page 11. Okay. So now we're going to use the combination of skills learned in previous exercises to solve equations that are more complex. So here's example 1 on page 9. The question says solve for x. So here we've got 3 to the exponent x plus 2 plus 3 to the exponent x plus 1 is equal to 12. So if I gave you the left hand side of this equation only gave you the left hand side, then what would we have done then? Like break up and take out the common factor. Not so. Break up and factorize. So what I'm going to do is I'm going to break that up there. So it will become 3 to the x times 3 squared plus 3 to the x times 3 to the 1 equals 12. Not so. So what is now common? 3 to the x. What am I left with? 3 squared plus 3 to the 1 equals 1. So how do I get the 1 with a variable on its own? How do I get 3x on its own? We divide both sides by 3 squared plus 3. So what is 3 squared plus 3 equal to? 12. So divide by 12 both sides. Of course that cancels. That gives us 1. So that means you say that 3x is equal to 3 to the x is equal to 1. But this 1 in this case would be 3 to the exponent 0. Anything to the power of 0 is of course 1. So therefore x is equal to. Is there any confusion here? Any confusion? No? Look at the next one. The next one is example 2. The example 2 is on page
2.
Okay. So here we've got 7 to the x equals 7 to the x minus 1 plus 6 over 343. So what are we going to do first here? We take 7 to the x minus 1 over to the left hand side, so that we can break up and factorize. So that will be 7 to the x minus 7 to the x minus 1 is equal to 6 over 343. Now what?
Break it down.
Break 7 to the minus 1 up, yes? So that will be 7 to the x minus 7 to the x times 7 to the negative 1 is equal to 6 over 343. Okay. Now what we do? So factor that 7 to the x, we take that out as a common factor. I'm left with 1 minus 1 over 7 to the minus 1 equals 6 over 343. What's 1 minus 1 over 7? 6 over 7, is that correct? Divide both sides by 6 over 7. So that's going to give us 1 over 49. Okay, so the first cancels. For those of you who are a bit tricky there with regards to that, we can just say it's 1 minus 7 to the negative 1. 6 over 7, of course, and then 6 over 343 divided by 6 over 7 gives you 1 over 49. Okay. But 1 over 49 can be written as what? So 7 to the x is equal to 1 over 7 squared. So 7 to the x is equal to 7 to the negative 2. So therefore, x equal to negative 2. Okay? Any confusion there? Any questions? Okay, let's go to the next one. Question 3. Example 3. Okay, this is a bit different. What do you notice? What is different here opposed to what we have done, compared to what we have done in the previous one? X is, or the 2 is 2 in front of the x, not so. So here we got 2 to the exponent 2x minus 3 times 2x minus 4 is equal to 0. So that 2 to the 2x. I can't take out 2x as a common factor here. Can you see that? So if I take that out, so you'll have 2 to the x times 2 to the x minus 3 times 2 to the x minus 4 is equal to 0. You take out 2x as a common factor, then I will be left with 2x minus 3, and only 2x is common there, equals 4. There's nothing we can do with it. Okay. But what you should note is that 2 to the 2x is also the same as 2 to the x squared. Can you see that? Because if a base is raised to a higher exponent, we multiply the exponents. You all understand it? So what I do is, when I get something like this, I say, firstly that can be written as 2 to the x squared minus 3 times 2 to the x minus 4 is equal to 0. So now I wrote 2 to the 2x as 2 to the x. Can you see that? As this is here. You see, people? Mr. Kanya, Michael, what are you busy with? What are you busy with? Now, why are you taking note here, Michael? Okay. You guys understand? So, we now introduce a variable to make the sum a bit easier to work with. Okay? So what we say let k equals 2 to the x. This is what we call k substitution. You could have let 2 to the x be an a or p or z or whatever. I just use k. And k is most often used. Okay? So we let k equals 2 to the x. So if I represent, wherever I see 2 to the x, what would this equation now read? K squared minus 3k minus equals 0. So what do we see now? Trinomial. Okay, so we can factorize this here, trinomial sum. Okay. So that would be k 4 and 1. What about our signs? Opposite signs, 1 plus 1 minus. The bigger product gets the sign of the middle term, which is negative. So there is negative and now what? K plus 1 is equal to 0, so K is equal to negative 1, or K minus 4 is equal to 0, K is equal to. But they haven't answered their question. The question was to solve for. So now 2 to the x is K. So I replace K with 2 to the x equal to negative 1. So, is this possible? Can I solve for x here? There's no way I can write negative 1 as a base of 2. So there's no solution here. You just put a line there. And if k is equal to 4, what is k? 2 to the x is equal to 4. So 2 to the x is equal to 2 squared. Therefore x is equal to? These bases are the same, exponents are? Okay? Yes? What don't you understand, Michael? Sorry? Where did I get k? Negative 3k. You see here? Wherever I see a k, wherever I see a 2x, I put a k. So there's a 2x, and there's a 2x. So this simply reads k squared minus 3k minus 4. Can you see that? K squared, k is now 2x. K squared minus 3k minus 4 is equal to 0. You understand? Any other confusion? No? And with that you should be able to now do exercise 1.5. And exercise 1.5 is on page 11. Could you do for me the odd numbers, please? Okay. If any issues, we'll sort it out. We'll do the first column, which is the odd numbers.